Alright, here we go. So, polar coordinates, right? You know how you graph x, y? You graph something in polar form, you base it from the radius to the angle. So it's like x, y is on theta, which means we're bringing back this thing. Alright, in trig, the cosine is which coordinate? X, and the sine is y. So very, very similar to what's going on. In polar coordinates, y is r sine theta, and then cosine is x sine. X is r cosine theta. The only reason why we throw an r is because now we can use it in any circle, not just a unit circle where r is 1. So it's the same thing. Alright, so here we go. Okay. When you're taking a look at a coordinate system, first of all, polar axis is usually your x-axis, right? So if x-y coordinates, it would be like the positive side of the x-axis. Well, in polar, you start with that positive side of the x-axis, measure your angles on the top, right? Your ending point right here, your terminal point is your r, so that's the radius, right? And then, so your point P would have r theta, so it's the radius. Right. So instead of x, y, it's the radius. Alright, so here we go. Point P, which is our theta, is located r, pull the absolute value point. Right? If r is positive radius, then it lies on the terminal side of theta, which means wherever it ends up, that's where it ends up. Okay? If it's a negative, if r is negative, like you have a -5 for radius, you go slide, and then you go so it'll be on the side opposite the terminal side of theta. We'll practice graphing this. Okay? And then if the radius is 0, then it lies at the pole regardless of the value. Okay? Oh, alright. 3 and 315. Okay? So this is the picture of the polar coordinate. So basically these circles are your radius. So radius 1, 2, 3, 4, and so on. Right? So it's radius of 1, 2, 3. And then I gave it to you in radians, so it's 350 and radians. Where? 7 power 4. So this is where 350 degrees is. That's 7 power 4, right? So to graph 3 in 7 power 4, from the center, you go out 1, 2, 3. So that is where this point right there is. Where is that? Very similar to that. Okay. No. Okay. So here's the deal. I is over here, right? And the radius is 2. So you would think that it would be over here, right? But you gotta flip it around. It's actually, okay? Because that makes it go opposite side. Makes sense? Okay. -1, -pi over 2. Where's -pi over 2? Yeah, this is also -pi over 2. So if it's -1, right? We go down, and then that comes again. So this, that point right there is -pi over 2. Okay? Because you would flip it, go down, and then back up. Well, no, but it's like, let's do some conversions. No! That's total anything. Alright. Here we go. Since it's polar, it goes round and around and around and around, right? How do you find another point that has the same radius and same terminal point without an add? There it is, 360, and in radius that is 2 pi. So to change an angle without changing the radius, just add 2 pi. If you do change the radius to a negative, right, then all you do is add pi to the angle and replace r with negative r. So it's the same as adding 2 pi. So if it wants a negative radius, then you just add pi to the angle and then all right. Continually adding or subtracting 2 pi, right, does not change the location of your terminal point. Okay? Okay. So practice. Let's say I have a point at 5 pi over 4, and I want to find another point where r is still positive. So to do this, keep the 5, right? Because r is still positive 5, and then take pi over 4 and add 2 pi. 5, 5. Okay? Okay. So take the same point, make r negative. Negative 5. Yeah. Plus pi, just add 180 to it. So it's negative 5, 5, 4. 4. Alright. R is positive, and you want it to be between 0 and negative pi over 2. So, yeah, just subtract 2 pi, just go the other way around. So, the 5, make pi over 4 minus 2 pi. Because it does matter if you add subtract 2 pi. Come on. So, go ahead, Alejandro. I feel like this is too big. It's just another Woo! Alright. Here we go. So this is where the trick comes in, right? Your 4 basic polar formulas. This is to help you to convert from polar to rectangular, which is also Cartesian and backwards. Okay? This time it's not just the unit circle, so r could be more than 1. So instead of just sine or cosine x is equal to r cosine. Yeah. Forward science, backwards and forwards. Because it's fun! Right? And why is r sine theta? Of course, you remember from the trig that x squared plus y squared equals r squared, good old Pythagoras. Yeah? And then tan is y over x. So, using those combinations of formulas, you can convert from polar to rectangular. It's alright, here we go. Ah! Alright. What? Oh goodness, here we go. Find the rectangular coordinates for the points with the following coordinates. First of all, we know that rectangular goes x, y, right? Therefore, it's r cosine theta, comma, r sine theta. Yeah? So, r is cosine pi, and then 3 sine pi. Yay? What's cosine pi? Negative 1, so it's 3 times negative 1, comma, 3 times 0. So, negative 3, 0 would be where it's at. Right? So, if you were to graph this polar, 3 pi would be the same thing as negative 3, 0. Does that make sense? Yeah, let's think about where it's going to be. That's negative 3, 0. Just a little bit. Okay, here we go. Alright, I'm just going to go straight to r cosine theta, yeah? Negative 10 cosine pi over 6, comma, negative 10 sine pi over 6. Woo! Cosine? Yeah. 6. True? sine pi over 6 is 30, right? So sine is 1/2 at 30. Is it true? Alright. Times 1/2. So -2 goes into 10, 5 times 2 goes negative, so -5 root 3, and 1 too fast. Awesome. Okay. What? Mulan? Moana? Oh, no, was it good? Oh, I heard they made like. Oh, man, that's like pretty there. Oh my god. Okay. Alright. There you go. Yeah. Color is just too much for this not smart board. Here we go. Down. Oh. Okay. Here we go. To change from rectangular to polar. Okay. Start by applying the point XY. Now this is a trick where you find the x, right? You find the radius by computing the distance from the function. There we go. And then using tan, yeah, to find theta, blah blah blah. Okay. Okay. Here we go. All right. So, coordinate -√3. What quadrant am I in? Yeah, this is quadrant 4. Right? So, here we are at, right? At 1, -√3. To find r is 1 squared plus -3 squared. So, 1 plus 3 is 4. Take the square root. 2. Again, we just use the formula x squared plus y squared equals r squared. So plug it in. Yeah? Okay. There we go. So this is your theta. So obviously our r is 2. Got that one. Okay? To find theta, we use tan of theta, which is opposite over hypotenuse, so -√3 over 1, which is -√3. Okay? And then using our handy dandy unit circle. What is it? Well, we're obviously in quadrant 4. True? Okay. So, you guys still have your unit circle, right? Okay. Well, here we go. So, wouldn't it be this one over this one? It has a negative here top. So, 5 pi over 3. So that is, okay. Alright. Awesome. Yay. So, if we use that, inverse tan it, it's 5 pi over 3. So, 5 pi is polar. Hey! Wait till we talk about bipolar. Just kidding. Those are Alright. Oh goodness. Here we go. Find the polar. Oh! I feel like this is too easy. Here we go. Yeah. Keep it like this. This is good. 0, -4. It's like right here. Okay. Okay. So what's the radius? Yeah. And what's my angle? Which is what radius? 3 pi over 4, -pi over 2, whichever. Yeah. Pi over 2, -pi over 2. Yay? Should we go the other way? Let's go the other way. I like it. Alright. Keeping these 4 formulas in mind. Okay? Hopefully you've seen them enough that you know it's pretty fun. Right? If not, alright. Alright. Woo! Let's go from rectangular to polar. Okay. Here we go. Alright. So we're going to express them in terms of r and theta. Okay? r sine theta equals 6. Right? When I express r in terms of theta was the r equals. So yeah, r is 3 cosine theta minus sine theta. So r is equal to, right? Wait. Yeah. That's good. Good. All right. One of this order. Yeah. All right. So I get that x squared is 6. Okay. Y squared plus what? Plus y squared plus 2y plus equals 1. And let's cancel out. So that's 0. What's x squared plus y squared? Hey! Plus 2 times y, which is theta equals 0. Okay? GCF is r. So this should be r times r plus 2 sine theta is equal to 0. So this one says that r is equal to 0, and this one says that r plus 2 sine theta is equal to 0. But r is equal to 0 is on the polar axis, so it's already part of this thing, right? It's on the polar axis, so already included. Yeah, into that second formula. Sure. So it's just the second formula that we need to solve. So this one, right, is r is equal to that's an equation. It's that. Yeah. Because r is we just need to solve it for r theta r equals to r. Okay. So good. Here's my favorite one. We're gonna get up. Going from polar to rectangular. What do we got? Thank you. If you square both sides, or in other words, multiply r. No, square both sides. Yeah. Square both sides, and you have x squared plus y squared. That's what it takes. Okay. Theta equals tan both sides. So tan theta is equal to tan 3 pi over 4. What's the tan at 3 pi over 4? Yeah. Yes. So tan is equal to -1, which means y over x is equal to -1, which means y is equal to -x. So is the equation. And r is equal to -2 secant. What? Oh, not inverse cosine. 1 over cosine. Yeah. So our r is equal to -2 times 1 over cosine. R cosine is -2. And what's fruits and vegetables. We're good. All right. Here we go. No, but I did have an extra cup of coffee there. Here we go. R equals 10 sine theta. It's a shame R isn't 10, because then that would just be y. Think about the first one that we did. By R. Thank you! Multiply R to both sides. Multiply R on both sides. You end up with R squared equals 10R sine theta. Whoa! R squared is, and R sine theta is, set it equal to 0 and you're done. X squared plus Y squared minus 10Y equals 0. And they always have after. Make this a polar picture? Yeah, we do. Alright, here we go. Oh, oh, yo, somos telephonos? I don't know. Yeah, we're good. Okay. Alright. Matt and Arya need to catch up with induction, so I'm here for questions. Yay? And then everybody else have your assignments. Yeah. Does anyone need to borrow unit circle? Oh, good.